We have all had a different experience with computing. If you are over 50 years old, then you would have finished your school career without ever seeing a computer. And if you're a teenager, you simply can't survive without the internet, and you're developing calluses on your muscular thumbs. The best way to appreciate these differences is to talk about the history of computers. We can only truly know where we're going to if we know where we've come from. You are probably expecting our story to begin around the 1940s, but it actually begins in 1823 with a man called Charles Babbage. Babbage was a mathematician, philosopher, inventor, and a mechanical engineer, and he is widely regarded as the father of the computer. In our previous video, How a Computer Works, we found that a computer is an adding machine that can process and store data. Storage is not necessary for our model, but increases the functionality of the computer. In 1819, Charles Babbage designed a difference engine. It was not programmable, but could do arithmetic calculations. In 1823, the British government gave Babbage £1,700, the equivalent to about 3.8 million rand in today's money, to start working on the project. The actual implementation proved to be extremely expensive, as the metalworking techniques of the era could not produce the precision and the quality required. The government abandoned the project in 1842 after Babbage had received and spent a staggering £17,000. In 1837, Charles Babbage went on to design an analytical engine that could perform arithmetic calculations, true and false statements, as well as loops and conditional branching. It even contained integrated memory. In 1878, a committee of the British Association for the Advancement of Science described the analytical engine as a marvel of mechanical ingenuity, but strangely recommended against constructing it. The committee acknowledged the usefulness and value of the machine, but could not estimate the cost of building it, and they were unsure whether the machine would actually function correctly after being built. To celebrate the bicentennial of Babbage's birth, the Science Museum in London decided to finally build his difference engine using his original plans. The difference engine worked perfectly, which proved his design and can now be seen in the Science Museum today. Herman Hollerith designed a punch card system to calculate the 1890 census and saved the government $5 million. That's the equivalent of 2 billion rand in today's money. He went on to establish a company that would become known as IBM. Alan Turing was a mathematician, a computer scientist, a logician, a cryptanalyst, a philosopher, and a theoretical biologist. He is regarded as the founder of theoretical computer science, and in 1936 presented a notion of a universal machine which would be capable of computing anything that was computable. This machine was later called the Turing machine. He is also considered to be the father of artificial intelligence. He designed the Turing test for artificial intelligence, which today has still not yet been passed. The first generation of computers lasted from 1942 to approximately 1954. These computers were characterized by the use of vacuum tubes. The simplest vacuum tube, the diode, was invented all the way back in 1904. They were found in radios, television, radar, recording devices, and telephone networks. They contain a heated electron-emitting cathode and an anode. Current could only flow in one direction through the device, so it operated like a switch. They generated a lot of heat, and like light bulbs, had to be replaced very often. They also required air conditioning and consumed huge quantities of electricity. They were very expensive and could only be afforded by very large companies. It would take a long time for vacuum tubes to warm up before they could even be used. They also resulted in extremely large computers, taking up entire floors of buildings. Two University of Pennsylvania professors, John Morchley and J. Presper Eckert, built the Electronic Numerical Integrator and Calculator, the ENIAC. It filled a 6-meter by 12-meter room and had 18,000 vacuum tubes. It is considered the grandfather of modern-day digital computers. 46 machines were made at a cost of $750,000 each. That is the equivalent of a little over 161 million rand in today's money. The ENIAC was primarily designed to calculate artillery firing tables for the United States Army. It could calculate a trajectory in 30 seconds that took a human being 20 hours to do. It was in continuous operation for the US Army until the 2nd of October 1955. As amazing as this computer was in its day, it would take almost 2 years for this machine to perform the number of calculations that a modern-day iPad can do in a single second. Maudsley and Eckert left the University of Pennsylvania to build the Universal Automatic Computer, the UNIVAC, back in 1946. This was the first commercial computer for business and government. In 1951, the UNIVAC predicted the outcome of the 1952 presidential elections with remarkable accuracy. It predicted an Eisenhower landslide when all the traditional pollsters expected Stevenson to win. In 1947, Bell Laboratories invented the transistor. The transistor was an electronic switch made from a semiconductor. This totally eliminated the need for vacuum tubes, which radically reduced the size of the computers and made them far more reliable. It also introduced the second generation of computers, beginning in approximately 1952 to 1964. All second generation computers made use of transistors. In 1958, Jack Kilby and Robert Noyce developed the integrated circuit, also known as the computer chip. Kilby was awarded the Nobel Prize for Physics in 2000 for his work. Noyce, unfortunately, had died of a heart attack in 1990. Integrated circuits form the basis of modern computers. They have large numbers of tiny transistors placed on a single chip. This lowered the costs and increased the performance. Integrated circuits also form the basis for the third generation of computers, lasting from approximately 1964 to 1972. Gordon E. Moore was the co-founder of Intel, and in 1965 he made an observation now called Moore's Law. It stated that the number of transistors in a dense integrated circuit doubles approximately every 2 years. His law has proven correct, with transistors in some central processing units as small as 10 atoms thick. The first processors in 1978 had 29,000 transistors. With the current i9 processor, 40 years later, they have an estimated 6.5 billion transistors on the single chip.